All right, I think this is kind of where we left off. All right, who wants me to discuss a proof? Which one? Number 10? All right, here we go. So now, MS is congruent. So I'm going to go ahead and just grab that. There you go, step 1. All right, and of course that's just the given. All right, so now I just have one piece. Right, how many pieces do I need?
3.
3, exactly. So I have one side. All right, now anytime somebody says parallel, the first thing that comes to mind should be something like what?
Parallel lines.
Parallel lines, yes. So what does that mean if two lines are parallel? Two lines are parallel, they're congruent. That doesn't make any sense.
Their
What?
slopes are equal.
Slopes are equal, but we're talking about this shape up here. Guys, you got to look up on the board now. Some of you guys are just saying things. Vertical angles have nothing to do with parallel lines. Absolutely nothing. Instead of just saying something, it's pertaining specifically to this problem. If they tell you, remember, every single piece of it has to be used. All right, we just used the fact that MS is congruent to RQ. That's given. And the other thing it says is the lines are parallel. We've already used this. We haven't used parallel. So they had to tell us it was parallel for a reason. Why? The alternate interior angles are what? Are congruent. So you can say this. Angle Q is congruent to angle what? S. Right? That's what I'm talking about when we say using parallel lines. So step number 2. Angle Q is congruent to angle what?
S.
Angle S. That's not a definition. That is simply saying what? The alternate interior angles. All right? And that was a theorem. If the lines are parallel, then the alternate interior angles are what? Congruent. All right? So you can put alternate interior angles are congruent. So angle Q is now marked. All right? Now here's where some of you could deviate a little bit from possibly the solution. All right? You could say what else? Dalton. Now, what vertical angles?
Was MSP and
MSP. Where do you see that's vertical? Come on. You said vertical angles. That's not vertical. There's only one set of vertical angles on that figure.
SPM.
Yes, there we go. He said number 3, angle SPM is congruent to what? I didn't hear you. RPQ. That's the vertical angle theorem. All right, so now we can mark it. This is congruent to this. So now are the triangles congruent?
Yes.
By what?
Side angle side.
By what? By what? Angle, side. Angle, side. That's one possibility. There is an alternative. The alternative would be to what?
Side angle.
Okay, what's the difference? Come on now, guys. What's the difference between side angle, and angle, side? Now, again, hey, girls.
It's kind of.
All right. The assignment now, I want you to look up here. This geometry book teaches a little bit different than the way I think it should be done. So I'm just going to modify something for you. So look up here. All right. Today we're talking about the what happens when you have right triangles. All right, what happens when you have right triangles? So please take a look now so I can show you. We are not going to write down leg-leg congruence. We're not doing that. What is leg-leg, really? Side angle side. Brilliant. For those of you guys who are paying attention, that is the same as side angle side. We're not writing leg-leg congruence. All right? Just like for the hypotenuse angle. We don't write hypotenuse angle. That is simply what? That is simply angle, angle, side. All right? We're not writing hypotenuse angle. Doesn't make sense. All right? The next thing is not leg angle, but what? Angle, side, angle. Now, the one that is necessary, but for me is obvious, all right, for the Theorem 4.9. This is necessary because we already said we cannot do what? Angle, side, side. We cannot do that.
No.
All right?
No.
We must call this the hypotenuse leg. All right? That is the only time in which you can have an angle, a side, and a side. So this is hypotenuse leg. The angle, side, side is hypotenuse leg. All right? So out of all of these right here, there is nothing new. Doesn't matter that it's a right triangle. Makes no difference. All right? We're not saying any of these right here. All right? We're looking at it as if it was side, angle, angle, side, angle, or hypotenuse leg. Those are our options now. So this is how you prove things. Side, side, side. Side, angle, side. Angle, side, angle, side, or hypotenuse leg. Those are the 5 different ways in which you can prove the triangles are congruent. All right, and then after that, generally it's what? CPCTC. Everybody's feeling good, right? Okay, so now what I'm going to do is I listed these 1, 2, 3, 4, 5 proofs. That's your homework, 5 proofs. All right, I didn't provide the answers for a reason. All right? I want them done. All right? I also want them printed out. Right? I want them printed out. The reason why I want you to print them out is because the figure is already what? Drawn for you, so you don't have to draw it on a sheet of paper. Is everybody with me? And then you're going to turn it in to me tomorrow. All right? And then I'm going to kind of look to see how you're doing. All right? Yes.
You want us to like print it out and then do it on the paper? You want us to just like do the work on the
Yeah, I prefer that you do the work on the iPad and then print it out. Isn't that? Or I would have just printed the paper for you or just make you write it on your own paper. If you want to write it on your own paper, feel free. Write it on your own paper. If you're worried about getting something printed out, just write it on your own paper. All right? But I think this is a better way to do it. All right? Hopefully you agree. All right, that's it for me. Get busy. 5 proofs. All right? They're mixed up a little bit. All right? Help each other out.
Do you think the reason they called it the hypotenuse leg instead of angle side side